Yolan gang, another crazy GCSE question. Well, it looks that way anyway. Again, sent to me on the Lung Gang Reddit. I have no idea where you guys are getting these questions from, but it looks mad. It says question 24 in wherever paper they found this, but it says the diagram shows a solid cone and a solid sphere. It says the cone has base radius r, slant height L, perpendicular height H. The sphere has radius R. The base radius of the cone is equal to the radius of the sphere. Given that K times the volume of the cone is equal to the volume of the sphere, show the total surface area of the cone is this, where A is a constant to be found. Mazaline. Well, that just looks mad in itself. I mean, that looks like the quadratic formula though, doesn't it? Okay, so like we've discussed before, when it comes to these problems, more difficult problems, is we always start with the given statement, right? What have they given us? K times the volume of the cone is equal to the volume of the sphere. K times the volume of the cone. So if you take the volume of the cone, you multiply it by some value of K, you get the volume of the sphere. So it means there's some kind of scale factor enlargement or making it smaller of the volumes. Well, we're just going to find the volume of the cone and the volume of the sphere, equate them, see what happens. Perhaps it's going to help us work out R or something like that. Maybe L or whatever. I'm not too sure, to be honest. This question is just mad. We'll see how it goes. So what's the volume of a cone? Now, the volume of a cone is... So you just need to remember this. It's a third of the base area times the vertical height. So it's a third of the base area. Now, because it's a cone, it's a circle at the base, a third pi r squared, so the circle, times the vertical height. All right? And then the volume of a sphere is 4/3 pi r cubed. So it's going to help us work out h then. So they're saying this times k equals this. All right? So k, lots of 1/3 pi r squared h equals 4/3 pi r cubed. Timesing both sides by 3, that cancels. Dividing both sides by pi, that cancels. Let me just write it cleanly, but you can divide by r squared. And let's just do it now. If I divide both sides by r squared, this cancels. R cubed divided by r squared is just r because you take away the powers, right? So we have kh is 4r. Okay? I feel like I want to leave it like that for now. Okay? So we have a relationship between the height and the radius. All right. But they want the total surface area of the cone. How do we work out the surface area of the cone? Now, the cone has the curved surface area. Now, the curved surface area is pi rl. Pi times the radius times the slant height. Pi rl. So our surface area, we'll call it the area of the cone, is pi rl, and the circle at the bottom, pi r squared. So the part of this problem we need to find is what is this value of L? All right. Well, this is very common. This is a cheeky Pythagoras' theorem because you have verticals, that height can be drawn in the middle, and you have this right-angled triangle. So it looks something like this. You have the slant height, you have the height of the cone, and you have the radius. All right, L, H, R. Yeah, that L could have been put here as well. What relates all of these together? R squared plus H squared is L squared. So R squared plus H squared is L squared. Oh, that's going to easily work out L. I say easy, but not really. We need R squared though. Oh no, wait. We want it in terms of R. We can find H squared. Here, we can divide by K and square everything. Or we could square it right now. If we square everything, we're going to get K squared. H squared is 16 R squared. All right? So we're going to divide by K squared. And that's going to pop in there. So we get R squared plus H squared, which is 16 r squared over k squared is L squared. And we need to root that, right? Now, what's the best way to root this? I feel like we need to do some factorizing because can you see they have brackets here and stuff. Yeah, factorizing probably would be a good idea. That's what my instinct is saying. I don't like that there's two separate fractions. So I'm going to write this over 1. Then we're going to times top and bottom by k squared to have a matching denominator. Now if I times top and bottom by k squared, this is going to become k squared, and so is that. We can bring it all into one fraction now. It's going to look like that. And we're just going to get rid of one of the k squareds. There's actually another thing I can do here, is look at the numerator. Can you see they both have r squared? We can factorize that out. And we're going to get L squared. When you factorize out the r squared, you're left with k squared plus 16, k squared plus 16, all over k squared. Nice. That's, oh no, there's no k squared plus a, what? K squared plus a, it looks like that. I think a is going to be 16, but we'll see. Because now we're going to square root, right? When we square root this whole thing, this is all one term, by the way, because this is being protected in a bracket, is we're going to square root this. It's going to maintain the positive because we're talking about length. That's going to be r and k. So I could write that further down. Let's just write that first. So square root that, r. This you're going to have to root, which is just k squared plus 16, over the root of that is k, is L. Nice, dude. So now we can go back to the original. So continuing on our working and substituting. Just make sure I don't get rid of too much. Is we have that area is pi r L. So that pi and r are going to multiply with the numerator, right? Because that pi r is like pi r over 1, right? So the pi r over 1 is going to multiply like this. The k is going to go with the 1, and the pi r are going to go with the r. Pi r times r is going to be pi r squared. Then we have this root of k squared plus 16 all over k plus pi r squared. All right? We're getting there. Ah, there's a k in the denominator. Nice one, dude. Now, we need to bring this all into one fraction. Yeah, you could factorize out the pi r squared if you want to, and then this would change to a 1. But I'm going to bring it into 1 first. So I'm going to write this over 1, but I want it over k, so we're going to times top and bottom by k. Bring it all into one fraction. So we get a is all over k. We have the pi r squared, root k squared plus 16, plus pi r squared k. And then from there, we're going to factorize out the pi r squared. Now when we factorize out the pi r squared, here, it can come out in the front, and then we're going to have a big bracket. We're going to cover up those pi r squareds, and there's your answer, k plus, so I'm going to write the k first, just like the answer, root k squared plus 16 all over k. And that is a beautiful question. You can see a is 16 there. And there you go. What do you guys think? Do you think that's harder or easier than the pentagon question I did earlier? Let me know your thoughts. Guys, like I said, if you learned something today, hit the like button. It helps me out a lot, and it means you'll reach, or these questions will reach a wider audience who may need this. And subscribe for more maths content. If you're interested in my GCSE courses, there is a link in the description. And I'll see you guys in the next video. Nice.